The following is Summer 2009 Math263 Test 3, number 3. Use Lagrange multiplier method to find the greatest and the smallest values of that the function this fxy equals to 4x cubed plus y squared takes on this constraint 2x squared plus y squared equals 1. Now there's a special note here. You need to find all critical points of this method. Now because we use Lagrange multiplier, then we will do the following. Let's define that the gxy, the constraint, be that one, 2x squared plus y squared equals to 1, and things we need to satisfy. The requirement is that the del f equals to lambda del g. At the same time, gxy should equals to 1, right? It has to satisfy these two requirements, which if we break up even further, you will see that the gradient of f will be, the gradient of function f will be 12x squared comma 2y equals to lambda. The gradient of g will be 4x comma 2y, and then the gxy equals 1 is a 2x squared plus y squared equals 1. Okay, now if I break it up even further into components, then you have 12x squared equals to 4 lambda x, 2y equals to 2 lambda y, and lastly the constraint. Now from the first equation, I hope you can see that either x equals to 0 or lambda equals to 3x, right? Now, you need to account for when x equals 0 though. You can't just cancel the 4x because x may be 0. Now likewise, the same idea for the second equation, either y equals 0 or lambda equals 1. Now let's see. If for x equals 0, I hope you can see right away, if x equals 0, then y cannot be 0 because of the third requirement, right? Now then, for that reason, you will see that if x equals 0, then I will plug it in 2x squared plus y squared equals 1, because x squared equals to 0, then y squared equals to 1, y equals to plus minus 1. Okay, now then you will see that one of the critical point will be 0 comma plus minus 1, in which the critical point, and you see p there, and the function on the value of the function f on 0 plus minus 1, you will see that's equals to 1, right? Now some of you may argue that this is not possible because if y cannot be 0, then lambda has to be 1, and if lambda equals to 1, it implies the x should be 1/3, which contradicts with the fact that x equals 0. Okay, now I will put it here for now, and we will see that this will not be the greatest nor the smallest value, okay, because of that possible contradiction actually. Now let's see the second possibility. What happened when the y equals 0? For y equals 0, of course, if y equals 0, then you can see that the x cannot be 0 because of the third requirement, right? And then for that reason, I will put the 2x squared plus y squared equals to 1, 2x squared equals to 1, x squared equals to 1/2, and x equals to plus minus 1 over square root of 2. Which implies the critical point from here will be plus minus 1 over square root of 2 comma 0. Now because of possible different values of the function, let me split it up. So f of 1 over square root of 2 comma 0, that will be radical 2, while f of negative 1 over radical 2 comma 0 will be negative square root of 2. Okay, now the third possibility is for lambda equals to 3x. Now when lambda equals to 3x, then what will happen? We also know that lambda equals to 1, right? It implies x equals to 1/3. Now from here you put it in. This will be 2 over 9 plus y squared equals to 1. So y squared equals to 7 over 9. Y equals to plus minus square root of 7 over 3. So that the critical points are 1/3, comma, plus minus square root of 7 over 3, for which the f of that the y happens to be an even function, right? The y happens to be an even function if we see here. Oops. And this will be, let's see, there will be 4 over 27 plus 7 over 9, which is, you will see, times 3, 21 plus 4 is 25 over 27. Okay, that's all the critical points possible. And what is the maximum then? This will be the maximum. It's more than 1, and this is the minimum. That's less than -1. Okay, that's for Summer 2009 Math 263 Test 3, number 3.